So a very good afternoon to all of you. Hope you are all fine at your places. Today we will discuss about the arc phenomena that will occur in case of a circuit breaker, and you see that how this arc will generate when the contacts of the circuit breakers are operated. That means when the moving contact as well as the fixed contacts are separated, when the fault occur in the system. So in that case, there is an arc generated, and you had discussed in my previous lecture that whenever there is an arc generated between the two contacts, that is a fixed contact as well as the moving contact, in case of a circuit breaker, so if this arc cannot quench within a minimum possible shortest time, so it will lead to damage the circuit breaker as well as it will lead damage to the system, because due to this arc the heat is generated so much and you have to extinguish this arc as soon as possible. Okay, now you can see that it will be written in this here, that arc phenomena, and before this thing we had discussed each and everything. Now what do you mean by this arc phenomena? As I had already tell you in my previous lecture, that when a short circuit occurs, a very heavy current flows through the contacts of the circuit breaker before they can open by the protective system. That means whenever there is a fault occur in the system, when there is a fault occur in the system, due to this fault a very heavy current flows in the circuit breaker, and due to this heavy current your magnetic coils, or you can say that your electromagnet, get energized, and when these are energized they are pulled apart your moving contact with the fixed contact, and hence the circuit breaker can operate. So the moment when the contacts begin to separate, the contact area decreases rapidly and a large current flows through it, causes increased current density and increase in the temperature. So the heat produced in the medium, that is between the two contact, is sufficient to ionize the air or vaporize the oil present in it. The ionized air or a vapor act as a conductor, and here the arc is struck between these two conductors. So you can say that you know that there is an air present between these two contacts, and when a very heavy current flows through between these two contacts, what will happen? It will ionize the air particles, and with the ionization of the air particles, you can say that with the an arc is generally set up in the between the two contacts. The potential difference between these two contacts is very small, and it is just sufficient to maintain this arc, because if the potential difference is high, then maybe this arc can be quenched. But here, in case the potential difference between the two contacts is very low, and it will be act as sufficient to maintain the arc. Okay, so during the arcing period, the current flowing between the contacts depend upon the arc resistance. The greater the arc resistance, the smaller the current that flows between the two contacts. So you have to see here that in order to quench the arc, or in order to extinguish the arc that will be generated between the two contacts, it's all depend upon the resistance of the arc. And if the resistance of the arc is greater, smaller current will flow, because you know resistance is directly proportional to length upon inversely proportional to the area of cross section. We know that the resistance means opposition to the flow of current. If there is a high resistance, that means there is a low current, and vice versa. If resistance will be low, then current will be high. So if the resistance will be high, a low current flow between these two contact, and it will be act as a media to quench the arc. So the arc resistance depend upon the following main factors. Number one, degree of ionization. Number two, length of the arc. And number three is the, you can say that, area of cross section of the conductors. Here the cross section area of the arc. So you can see that when you talk about the degree of ionization, the arc resistance increases with the decrease in number of ionized particles between the two contacts. So here you should must be having a knowledge about that. In order to quench the arc, between the two contacts of the circuit breaker, the resistance of the arc is quite low. If the resistance of the arc is low, in turn, the current is, sorry, in order to quench the arc, the resistance of the arc is high. So when the resistance of the arc is high, then the current flows between the two contacts is low, and hence when there is a current low, the temperature is also low and arc will be quenched within a minimum possible shortest time. So in order to increase the resistance of the arc between the two contacts, these arc resistance is dependent upon the three main factors. Number one will be degree of ionization, number two will be length of arc, and number three will be the cross-sectional area of the arc. As you know, resistance R, that is directly proportional to the length and inversely proportional to the area. So that means if you increase the length of the arc, that means if you increase the length between the fixed contacts and the moving contact, obviously the length of the arc will increase. And when the length of the arc is increased, since this length is directly proportional to the resistance, hence the resistance is also increased. And when the resistance is increased, the current will start decreasing, and then the current start decreasing, the arc will be quenched with the minimum possible shortest time. So this is the one way by virtue of which you can extinguish the arc within a minimum possible shortest time. Because you know that whenever the circuit breaker has to be operated, whenever the circuit breaker has to be operated, the moving contact as well as the fixed contact, the moment when they are get apart, due to the you can say that the presence of the air ionization, the arc will generated, and you have to be quench this arc within a minimum possible shortest time. And for minimum possible shortest time quenching the arc, it must be clear that the resistance of the arc is very, very high. Because if the resistance of the arc is high, that in turn the current flowing through the contacts will low, and hence the arc will be quenching in a shortest time. So for you can say that increase the resistance, you have there are three important terms that you should be kept in mind. Number one will be the degree of ionization, number two will be length, and number three will be the area of cross section. The length of the arc that I had already explained to you, that if you increase the length between the moving contact as well as the fixed contact, the length will increase, and since this length is directly proportional to the resistance, the arc resistance is also increases. And when this arc resistance is increases, the current is decreasing, and with the virtue of this thing, the arc will be quenched within a minimum possible shortest time. Second point, the area of cross section. You know that the area of cross section is inversely proportional to the resistance. That means if you increase the area of cross section of the arc, the resistance will decrease, and when the resistance will decrease, the current will start increasing, which is not you can say that the favorable condition for a circuit breaker has to be operated. Because in case of a circuit breaker, the favorable condition is that thing, whenever the arc generated between the two contacts, this arc will be quenched at a minimum possible shortest time. So for that thing, what you have to do, your area of cross section will be low. When the area of cross section low for the arc low, that means your resistance will very, very high. And when the resistance is high, that in turn, you can say that your arc will generate within the contacts is get extinguished within a minimum possible shortest time. So by the virtue of these two, we have basically the three main things, that is degree of ionization, the length of the arc, the cross section area of the arc. But by the virtue of this, that is the length of the arc as well as the area of cross section of the arc, but with the increase in the length, the resistance is increased, and hence the arc will reduced. And second thing will be with the decrease in cross sectional area, the resistance of the arc increases, and when the resistance of the arc increases, ultimately your arc will be stuck in a very shortest possible time. In addition to that thing, you have also the degree of ionization. Degree of ionization means, you know, there is an ions present in the moving contacts as well as the fixed contact. And whenever there is an arc occur between the moving contacts as well as the fixed contact, your ionization process will start. So the arc resistance increases with the decrease in number of ionized particles between the two contacts. So what does it mean? It means when there is a decrease in ionization of the particle, the arc resistance is increases. So when the arc resistance will increases, ultimately your arc will be stuck within a minimum possible shortest time. Okay, so here you can see that how the arc will generated between the two contacts of the circuit breaker, and in order to quench this arc is ultimately dependent upon the three main factors: degree of ionization, length of arc, and the cross sectional area of the arc. So by changing out of these three, if you change the length of the arc, if you change the cross sectional area of the arc, or if you change the degree of ionization, by the virtue of one or two or three things, your arc will be extinguished within a minimum possible shortest time. So I think you can now understand that how the arc will generate in the two contacts of the circuit breaker, and whenever there's an arc generated, you have to quench the arc, you have to extinguish the arc. And for extinguish the arc or quench the arc resistance should be very very high. And for arc resistance should be high, it will depend upon these three main factors. Okay, so here it will be also write down that the principle of arc extinction, this principle of the arc extinction is same that I had tell you in my just now, that it is all depend upon how the arc will be extinguished. Now here the question comes that arc extinction. Now in case of an arc extinction, there are basically we can use the two main methods in case of circuit breaker. One is called as the high resistance method, another is called as the low resistance method, or the low resistance method is also called as current zero method. So you can see with this high resistance method or low resistance method or current zero method, we can extinguish the arc in a very very shortest span of time. So high resistance method, what will happen in case of high resistance method, that I had already tell you, you have to increase the resistance, and when you have to increase the resistance, in that case your current is reduced, and when then current is reduced, the arc is extinguished. So in case of you can say that high resistance method, the resistance method, how you can achieve this high resistance. So there are basically the four ways by which we can achieve this high resistance method. Number one will be lengthening of the arc, that I already explained to you. Increase the length between the moving contacts as well as the fixed contacts. When you increase the, you can say that the distance between the moving contact and the fixed contact, obviously the arc length will increase, and when there is increase in the arc length, your resistance will also increase. This is the number one method by the virtue of which you can increase the resistance, and with the increase in the resistance, you have arc will be extinguished. Number two will be cooling the arc. Cooling the arc means you can provide a certain natural cooling process or by another forced cooling process. Now here what will happen when there is an arc generated between the two contact, this arc will be extinguished or quenching with the help of some forced cooling method or some natural cooling method. So here we can use a blow of air, we can use a blow of you can say that oil, we are using a blow of gas, we are using a vacuum. So by adopting out of these four ways, one of the way you can adopt, and by adopting this way you can also increase the resistance of the arc, and when there is increase in the resistance of the arc, your arc will extinguish within a minimum possible shortest time. So this is the second method by the which virtue of which you can increase the high resistance method, or you can increase the resistance of the arc. Number three, that is called as a reducing cross-sectional area, that I had already explained to you, that you can reduce the cross-sectional area of the contacts of a moving coil as well as your fixed contact. So whenever you can reduce the cross-sectional contacts of the arc, ultimately your arc will be extinguished. And number four will be, there is called as a splitting of the arc. Splitting of the arc, as the name suggests, split means you have to splitting the arc into a smaller arc in series, so that it after certain time these arcs will be extinguished. So by adopting out of these four methods, that is lengthening of arc, cooling the arc, reducing the cross sectional area of the arc, and splitting the arc, you can achieve the high resistance method. And when there is a high resistance obtained, which will effectively, you can say that reduces your arc, and hence arc will extinguish within a minimum possible time. Okay. Now, second method, if I talk about, that is called as a low resistance method. Now, in this case, this type of arc extinguish is can be carried out only in AC circuit breakers. Now, mind it, one important point that you should kept in mind, that this high resistance method can adopt in both DC circuit breakers as well as AC circuit breakers, because depending upon the input supply, if you have an AC input supply, the circuit breaker here we can use is called as AC circuit breaker. And if you have an input supply is DC, so in that case, you can say that it is a DC circuit breaker. So a high resistance method can be adopted in AC circuit breaker as well as DC circuit breaker. In both the circuit breaker, this high resistance method can be adopted to quench the arc. But on the another hand, the low resistance method, or called as a zero current method, is adopted only and only in case of AC circuit breaker. In case of DC circuit breaker, this type of current zero method or low resistance method cannot be adopted. So what will happen in this method? Arc resistance is kept low until the current is zero, and where the arc extinguished naturally, it prevents from restriking in spite of rising voltage across the contact. So in all the high modern AC circuit breaker, we are basically using this method, that is current zero method or low resistance method, to extinguish the arc. Here you can write down, in the AC system, current drops to zero at a every half cycle, because you know that in an AC, current will start increasing from zero, reaches to maximum at 90°. That is, it's called as the peak value or the maximum value. After the 90°, it will start decreasing, and at 180° or 2 pi, the current will become as zero. So after that, this cycle will repeat. So here it can be write down that in case of an AC system, current drops to zero at every half cycle. At every current zero, the arc extinguished is a brief moment. Now the medium between the contact contains ions and electron, so that it will has a small dielectric strength and can be easily broken down by rising the contact voltage, known as restriking the voltage. That means whenever there is a current zero, there is a, you can say that the point in the AC, at in an AC wave, you know that at every half cycle the current remains zero, and after that the current will start again increasing, because in case of an AC, the current as well as the voltage are performed in a sinusoidal way. So the moment when the current will become as a zero, in this case, it is the best way to extinguish the arc. And in that case, when the current is become equal to zero, the ions and the electrons which are present in the ion gets designified, and hence the dielectric strength of these ions as well as the electrons present in the arc is get quenched, and hence your arc will get quenched by using this method. So this method we can use only in case of an AC circuit breaker, but in case of an DC circuit breaker, we cannot adopt this type of you can say that quenching the arc. So again, as in a high resistance method, the low resistance method or zero current method is also performed by the lengthening of the gap, high pressure, cooling, blast effect. So by the adopting of these four techniques, you can say that you can quench the arc within a minimum possible shortest time. So by the virtue of this thing, you can quench the arc, and when the arc will be quenched, then the circuit breaker will operate normally. There is no hard effect in the circuit breaker. Okay. So I think you can get an idea that how the arc will generated inside the circuit breaker, and how this arc will extinguished, or you can say that quench within a minimum possible shortest time, so that you can get an circuit breaker operated in a mean condition. So now today, what you have to do, all of you having a book of VK Mehta, this is the all the theory related to the VK Mehta. You are all directed to please go through this study material, that is arc phenomena. What do you mean by the arc in case of a circuit breaker? How this arc will depend upon the factors? What is the principle of arc extinction? The methods of arc extinction, that is high extinction method, high resistance method, and the low resistance method. You kindly go through it, study it, and if you face any problem while discussing these things, we will discuss in our next lecture. Okay. So in next lecture, we are discussed about some important terms, that we are used in circuit breaker, that is called as arc voltage, restriking voltage, RRV voltage. So these are certain, you can say that the terms that we can use in our circuit breakers. And after that, we will go towards the classification of the circuit breaker, like we have oil circuit breaker, gas circuit breaker, air blast circuit breaker, as well as the vacuum circuit breaker. Okay. So now, anybody having any doubt now today's lecture, he or she can ask me now.
सर ये दूसरा वाला टाइप रिपीट करना.
कौन सा वाला?
सर ये जो दूसरा वाला टाइप आपने बताया,
लो resistance or zero current.
Yes sir.
Basically what will happen in case of a low resistance or a zero current method, this type of method, low resistance or zero current method, can be adopted in your AC circuit breaker only. So in case of an AC, we know that the current will start increasing from zero, reaches to the maximum value, and after that it will start decays to zero again at 180 degree, because in an AC your current or the voltage is basically a sinusoidal. It will start from 0 to 190, 90 to 180, 180 to 270, and after that 360, the whole cycle will complete. That means in case of an AC, there are two cycles. One is called as the positive half cycle and another is called as the negative half cycle. So if you talk about the time period for AC positive half cycle will be equal to 0.01 second. It is called as a 1 microsecond. So you can see that at every 1 microsecond, the current will become as zero. Okay, because the current will start at 0 degree, reaches to maximum at 90 degree, and when it reaches to at 180 degree, it will become as zero. And after that, the cycle will repeat, so that you can say that a pure AC wave is available. Now, what will happen when the current will equal to zero? The point when the current will equal to zero, in this case, in that circuit breaker, when current is equal to zero, the dielectric strength of ions as well as the electron present at that particular time is get splitted off by some cooling media is there, by blast is there, कुछ ना कुछ दे के हम जब करंट की वैल्यू जीरो होती है, जिस पॉइंट पे करंट की वैल्यू जीरो होती है, उस टाइम पे जो आर्क जनरेट हुई होती है, उस आर्क को हम लोग क्विंच करते हैं, उस आर्क को हम लोग एक्सटिंग्विश करते हैं बाय प्रोवाइडिंग एक्सटर्नल एनर्जी. एक्सटर्नल एनर्जी का मतलब हो गया बाय प्रोवाइडिंग ऑयल. वो ऑयल क्या करता है, उसकी डाइलेक्ट्रिक स्ट्रेंथ को ब्रेक करता है आर्क की. बाय प्रोवाइडिंग एयर, वो एयर क्या करती है, एयर ब्लास्ट हम भेजते हैं, एक हवा का ब्लास्ट भेजते हैं, जिसकी वजह से आपकी आर्क जो एक्सटिंग्विश होती है. हम एक ब्लास्ट भेजते हैं गैस का, SF6 गैस, सल्फर हेक्साफ्लोराइड गैस का एक मतलब ब्लास्ट भेजते हैं. सो उस पर्टिकुलर पॉइंट पे, जिस पॉइंट पे करंट आपकी जीरो होती है, उस पॉइंट पे हम ये ब्लास्ट देते हैं. और इस मेथड में क्या होता है, जब करंट आपकी जीरो होगी, तो दैट मींस उस केस में हमारा जो सर्किट ब्रेकर है, उसमें जो आर्क जनरेट होती है, वो आर्क आपकी क्विंच हो जाती है. दिस इज द वे जिसकी वजह से हम लोग इस आर्क को क्विंच करते हैं. बट दिस टाइप ऑफ टेक्निक कैन adopted only and only in case of an AC circuit breaker, because in case of a DC circuit breaker, there is a no time when we have current is equal to zero. In case of a DC, there is a continuation wave flows on, but only and only in case of an AC, there is a wave. So that is why when at 180 degree angle or at a 2 pi radians angle, the current will become as zero, and at particular time, by adopting external agency, by using a blast of oil, by using a blast of air, by using a blast of gas, we can quench this arc. Okay.
ठीक है सर.
So that's why in next we have classification of oil, circuit breakers, where you have discussed the oil circuit breaker, gas circuit breaker, air blast circuit breaker, vacuum circuit breaker. So all these type of circuit breakers we can use in our AC fundamental. So from there you can see that how this arc will quench in a minimum possible shortest time. Okay. So
Sir, I have one more question.
Yeah, please.
Sir, in high resistance method वहाँ पे लिखा हुआ है कि reducing the cross section of the arc. जब area decrease होगा ना cross section का, तो voltage increase क्यों होगी सर?
नहीं, वोल्टेज इंक्रीज नहीं होगी. व्हेन एरिया आपका रिड्यूस्ड होगा, तो एरिया इज इनवर्सली प्रोपोर्शनल टू द रेजिस्टेंस, इजंट इट? बिकॉज़ आर इज डायरेक्टली प्रोपोर्शनल टू लेंथ, इनवर्सली प्रोपोर्शनल टू एरिया. सो व्हेन एरिया इज लो, दैट मींस रेजिस्टेंस विल हाई, and when resistance will high, the current will low, and when current will low, that means the temperature will low, and ultimately your arc will stuck out. There is a no relation between the area of cross section with the voltage, because the circuit breaker operates only and only when there is a high current flow in the line. So whenever there is a high current flow in the line, you have to extinguish the arc. And for extinguishing of the arc, that means your resistance of arc will be very, very high. When the resistance of the arc will be high, the current will low. So in order to lower the current, your resistance will has to be increased, and resistance increase can be achieved only by the two ways: if you increase the length, or if you to reduce the cross sectional area. So when you reduce the cross sectional area, ultimately resistance will increase, because R is inversely proportional to A. So when resistance is high, ultimately current will low, and hence the arc will quench.
Got it, sir.
Okay, fine.
Yes, sir.
Okay, bache.
सर
So
वन क्वेश्चन सर
this is all about, yeah, please.
सर जो आपने ये बताया ना स्प्लिटिंग द आर्क सर वो थोड़ा बताइए
So splitting the arc means whenever you have an arc generated, it arc is having a certain, you can say that the magnitude, or it having a certain, you can say that the potential. Splitting means you are divided this arc in number of ways. By in case of, you can say that simply in simple language, we can say that a main arc will be splitted in number of small arc. So by splitting of main arc into the number of arc, the dielectric or the ionization of the particles get reduced, and ultimately your arc will, you can say that, quenched. ये वही चीज हो गई, जैसे आपने एक बड़ी मतलब एक बड़ी आग को बुझाना है, तो आप क्या करिए, उस आग के छोटे 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 पार्ट्स कर दीजिए, तो छोटे छोटे पार्ट्स को आग को क्विंच करने में कम टाइम लगेगा एज कम्पेयर टू बड़ी आग को क्विंच करने के। तो वही फिनोमिनम यहाँ यूज करते हैं। ओके
ओके सर
So again, I will request all the students to be present there. You all are having a book of VK Mehta. Go to the page number 460. Start reading, start understanding what do you mean by this circuit breaker, and what do you mean by circuit breaker, how does circuit breaker operates, what is an arc phenomena, how you can extinguish the arc, what are the various methods, that is a high resistance method as well as the low resistance method. And from tomorrow onwards, we will discuss about the important terms used in circuit breaker, and after that we will discuss about the classification of the circuit breaker. Okay, now it's the time for the attendance. It's the time for the attendance. I will share the link of Google form in your chat box, so all the students are requested to please mark your attendance on a Google form provided on the chat box, and after that you can leave this platform. Thank you so much for
Sir?
Yeah,
सर जिनके पास जेबी गुप्ता सर वो
जेबी गुप्ता से पढ़ लीजिए, देखिए प्रिंसिपल सेम रहता है, सर्किट ब्रेकर वही रहता
तो
है,
कुछ मटेरियल मिलेगा
सब कुछ है, जेबी गुप्ता में भी सब कुछ है, बट ये है कि वीके मेहता में आपको क्या है कि प्रॉपर नोट्स की फॉर्म में दिया हुआ है, मतलब आपको, तभी मैंने वीके मेहता की पूरी बुक को डाउनलोड करके आपके सामने रखा हुआ है। ऐसा कुछ नहीं है, यू इफ यू हैव अ जेबी गुप्ता, इफ यू हैव अ स्टीवनसन, इफ यू हैव अ बीआर गुप्ता, किसी भी बुक से पढ़ सकते हो, कोई इशू नहीं है।